In today's note, we're going to be looking at annuities. So what an annuity is, it is a regular payment over a fixed period of time. So an example of something like this could be, say, a mortgage payment, because you're paying the same amount or a certain amount every month, and there's interest on that. You could think of it as a regular period of saving money, so you're putting in say $100 every week or something like that. So what we're doing today is we're basically using the TVM solver, but now we're incorporating the PMT, or the payment button. So again, just remember, or a refresher, N is the number of periods, and this was basically calculated by doing years times the compound number. I% is just the interest rate, but the key thing is, remember, when we're using the TVM solver, is that we're using it as we have to enter the interest rate as a percent, not a decimal. The TVM solver does all that calculations for us. PV is present value. PMT is the payment amount. FV is your future value. P/Y, or PPY, is the payments per year. And CY, or CPY, is the compounding periods per year. And again, if we're using a graphing calculator, you want the PMT at end, which means payment, or payments at the end of each period. But when we're using this online one from GeoGebra, you don't have to worry about the PMT at the end or the beginning. So those are, again, just a review. We've already covered those in the last kind of lesson looking at this. But what we're going to do is now incorporate the payment amount. So we're going to look at questions where we have to incorporate payment. So, for example, when their son was a month old, and at the end of every month thereafter, Chris and Ashley invested a total of $75 into an RESP, which is just a registered education savings plan that paid 6.45% annual interest, compounded monthly. So we need to determine the amount in the fund on the child's 7th birthday, 10th birthday, and 14th birthday. So we're going to look through this. We're not going to be using any calculations by hand, except for a few small ones. And then other than that, we're just going to be using the TVM solver. So we're going to go through, make sure we fill in all of our information, and then plug it into the TVM solver to solve. So the first one is going to be 7th birthday. Then we're going to look at the 10th, and then the 14th. So our N value is, again, remember, the number of compounding periods in total. So because it's 7 years times 12 months, that is going to be what our N value is. So 7 years times 12 months, we have a total of 84 compounding periods. Our percent is 6.45. We're going to leave it like that. Our PV, we're going to start at 0 because we're going to have $0 in there when we start saving. Our PMT, so our payment, or our monthly payment, is $75. Our future value, we don't know, so we're going to leave that blank. Our payments per year is 12 because we're making 12 payments every year or every month. And the CY is going to be 12 because it is compounded monthly. So again, just going back and looking at the question, that's where we get those key numbers from. Once we have those numbers, we can go over to our TVM solver to the right here, and we enter in these values. So 84, 6.45, PV is 0, PMT is 75, FV we're going to leave as 0 because we're going to solve for that. PY and CY are both 12. And then we just click solve for FV. So that is how much money is in there, or that's how much money we have after 7 years. So we have $7,936.03. Now what we're going to do is we're going to move on to the 10th birthday. So how much would there be in the fund after the 10th birthday? So the only thing that's going to change here is going to be the end value. The 6.45 is the same, the PMT is the same, the FV is the same, the PY is the same, the CY is the same. The only thing that changes is the N. So now we have 10 times 12, which means there's 120 periods. So we can go through, we can go back and just change the N value to 120 and click solve for FV, which gives us our new value. So we might have to click into it because it is going to be a little bit larger. But when we click on it, we can see that the new value is $12,595.78. Again, don't worry about the negative, just focus on the number. If we're finding after the 14th birthday, again, the only thing that's going to be changing is the N value. So everything else is going to be the same because we're just going to continue on, or basically assume we're starting back at the beginning. And because we're using the TVM solver, it makes it easier to do that. We don't have to worry about adding on to the previous question. So 14 years times 12 months a year, we get a total of 168 compounding periods in total. So we're going to go back to the TVM solver. The only thing we're going to change is the N value to 168 and click solve for FV. And you should see a change now. So we have $20,386 or $20,386.53. So you may have to just click on that actual number and scroll over to see the actual decimal places. Again, it may only seem like decimal places, but when you're dealing with money, you don't want to give away anything. So that's using the TVM solver to see how much would be in the account after those time periods. So what we're going to do now in B, we want to know by the time their son turns 17, how much of their own money had Chris and Ashley invested. So this is a key thing here, their own money. And this is where the payment comes into play again as well, because they're making monthly payments of $75, and they're doing that for 17 years. So if they're doing monthly payments for 17 years of $75, that means that if there's 17 years, so 17 times 12, do this separately, 17 times 12 means there's 204 payments. So if we want to figure out how much of their own money they put in, we can do 75 times 204, or for every month in those 17 years. And we get a total of 15,300. So for C, if we want to know how much did their RESP earn, or basically how much was in the actual fund, because again, remember this value here, the 15,300, is not how much the account or the plan actually has. We need to figure out what the final is. So we need to use a TVM solver to figure out how many or how much they're going to have when their son turns 17. Again, it's basically like the first three examples we just did. The only thing we need to change is that N value, which in this case, it now becomes 204, which we already figured out. And then once we do that, again, click FV to find our new value. So to use a TVM solver, we found that we got $27,696.17. So that's just from the TVM solver. So That's the total amount. So again, to find how much interest we actually earned, we need to take that total amount, the $27,696.17, and subtract how much of their own money they put in, which we got from the last question. So, and once we do that, we subtract them, and we should get that they earned in interest a total of $12,396.17. So that is how much they actually earned in interest. Again, remembering these calculations, similar to compound interest, they only give us the total final amount. We have to do a little bit of math to figure out what the interest is. For D wants to know if Chris and Ashley wanted there to be $30,000 saved by the time their son was 17, how much would their monthly deposit have to be? So this is going to be a little bit different, but we can still use the TVM solver to help us solve this. So I'm going to write out what we need to know. Again, our N, because it's 17 years, is 17 times 12, which gives us 204. Our I percent is going to be still 6.45. Our present value is still going to be 0 because we would start with 0. Our PMT, we don't know because that's what the question is asking us to find. They want to know how much would their monthly deposit have to be. Our FV, we know our FV, or our future value, has to be 30,000 because that's how much they want to have in the future. Our P/Y is still 12, and our C/Y is still 12 as well. And then once we use this or figure this out, we just go to our TVM solver. The only thing we have to change here is our FV to make it 30,000. We're going to change our PMT to just 0. And now we just have to click, instead of solve for FV, we're going to click solve for PMT. And we get 81.24. Again, avoid the negative. Don't worry about that. 81.24. So basically, therefore, the monthly deposit would have to be $81.24 to have $30,000 in 17 years. So that's how much they would have to pay, or that's what their payment would have to be, or how much they would have to save every month in that fund to get $30,000 in the end. So again, the only difference between this and the previous notes is now that we're adding in a regular payment or an annuity. So that's something you have to take into consideration. But other than that, all the other values are things that we would have done in previous lessons, and using the TVM solver is the same as before. So what you're going to do now is work through these questions. Again, some of them may not require the TVM solver, like for number 1, and so on. The other ones you would have to do that, use the TVM solver, so make sure you're reading the questions carefully. Again, if you're trying to find the TVM solver, you can just Google TVM solver GeoGebra, as you can see up here to the right, GeoGebra, and that should take you, or you should get the first link, and it should take you to this green little online TVM solver.